Greetings, M squared here, and today we are going to talk about exponential functions again. And today's lesson is just about looking at a function and being able to tell whether it's a growth function or a decay function. So exponential functions are either one of those. It's either growing, which means we're going up from left to right as x increases, y increases, or it's decaying, which means as x gets bigger, y decreases, goes down. So there are some really big things that we use exponential functions for. Banking, so interest rates, like how your money is in an account and it gains interest and it grows, and the more money you have, the more money you get in interest. That would be this kind of function right here. So we use that for another thing we use it for is population growth. A dog has 7 puppies, and those 7 puppies get older, and then they each have maybe 7 puppies, and they can have that twice a year. And pretty soon, 7 becomes, 7 times 7, and then 7 times 7 times 7. It grows really fast. Decay, we use that for population decrease. It could happen too. We could also use that for decaying, like when an element has a half-life, then we see that decrease, like the decay function. So there's different things we use it for. In science and in business, you'll see exponential functions. What we want to know today is how can you look at it and tell whether it's a growth or decay? Let's remember, f of x is just the function name. A is the initial value. That's what you're starting with. We talked about that last time. A can never be 0. If it's 0, then the whole thing is 0. So nothing's going to grow or nothing's going to decay. So A will never be 0, but it can be anything else. B has some limitations. It has to be greater than 0. It cannot be negative, and it can never be 1. Why can't it be 1? Because if I have 1 to some power, that always is 1. 1 times 1 times 1 times 1. So this would just be a linear function. It would just be f of x equals a if b was 1. So b has to be greater than 0, and b is not ever equal to 1. So there's a word that I want to talk to you about. We're not going to get into this year because of our limitations on time, but this word asymptote, I at least want you to hear the word and understand what it means. It's a line that a function gets closer and closer and closer to, but it never actually reaches. And you'll see that when we make our tables too. But when you look at this, the x-axis right here, you'll see that this function comes down. It's going to get closer and closer and closer to the x-axis. It's actually never going to touch the x-axis because you're always going to be taking half of it and then half of that number and then half of that number. And eventually it will be really close to 0, but it will never get to 0. So let's take a look at how we can tell whether a function is growth or decay. The key is when b is greater than 1, it's growth. When b is between 0 and 1, it's decay. So that is the key right there. If you remember those two things right here, bigger than 1, growth, between 0 and 1, decay, you'll be golden. So we're just going to circle all the exponential functions that deal with growth. So really we're just looking at that constant ratio, that b value. So I look right there, 1.5. Is it bigger than 1? Yes, 1.5 is bigger than 1. Okay, that's a growth model then. 0.98, is that bigger than 1? No. So that's a decay model. We're not going to circle it because it said only circle the growth functions. 1.02, is that bigger than 1? Absolutely. 1.02, I might have said 1, is bigger than 1. So it's a growth model. 0.85, not bigger than 1. That's a decay model. 1.05, definitely bigger than 1. It's a growth model. So in the lesson that you're going to have for tomorrow, not today, is you're going to realize that 1.01 is actually telling you that the growth rate is 5% because of that 5 right there. So we need to remember how to change percents to decimals to percents, because they're going to give you an equation like this and they're going to ask you, hey, what's the growth rate or what's the decay rate? So this is a real quick lesson today on changing decimals to percents. So to change decimals to percents, let's remember what percent means. Percent means per 100. That means out of 100. So whatever this value is, it means per 100. So 5 per 100 is 5%. And if you actually divide that, you get 0.05. When you are changing to a decimal, you divide by 100, which is the same thing as moving the decimal over 2 places. If you're taking a decimal and change it to a percent, you're multiplying by 100. So you would take 0.05 and multiply it by 100, and you would get 5%. Or you just move the decimal over twice. So the shortcut is moving the decimal over twice, but you need to understand that what you're doing is multiplying by 100. So if we want to change these to percents, we're going to multiply by 100. So let's multiply by 100. Okay, that would be 50%, because 0.5 times 100, if I move it over once, that's multiplying by 10. If I move it over again, that's multiplying by 100. Let's change 5.2 to a percent. So that would be 1, 2, multiply by 10, which is 100. So 520, 520%. Okay, how about this one? That would be 170%. And how about this one? 1, 2, that would be 3.5%. And I just wanted to have you do that real quick. So you're going to have a little bit of changing decimals to percents on your quiz, but then tomorrow you'll get into the more of the details on how it applies to an exponential function. Good luck. M Squared signing out.